So again, the beginning of a new section. And again, I'm really just encouraging those of you guys who are not happy, all right, just start fresh now. All right, I promise you it's not too hard. It is not too hard. It's just you're knowing the information, right? Nothing to it whatsoever, all right? So today we're going to talk about a lot of different things. And so what I did was, instead of going through, I just went ahead and cut them out of the chapter, and we'll just kind of look through the highlighted parts, all right? So the first thing it says, all right, is the perpendicular bisector, all right? You learned that a segment bisector is any segment, line, or plane that intersects a segment at its midpoint. If a bisector is also perpendicular to the segment, it is called the perpendicular bisector. All right, now, in many cases, what I try to show kids is if I were to draw a segment, all right, let's see if you can make some type of conclusion. All right, here is a segment, all right, and I'm going to try to draw a perpendicular bisector. All right, so what I'm going to do now is I'm just going to grab this and try to move it over so it looks perpendicular. Or I think that's pretty close, would you say? Not too bad. All right, that looks like a perpendicular bisector. Now, there are lots of lines that bisect that. Right? For example, does everybody agree if I draw this right here, that also bisected that segment? Do they agree? Because the segment is still cut in what? The segment is still cut in half, so that point, or those two segments are equal. Now, why is the perpendicular bisector just different?
Because it forms four right angles.
It forms four right angles, that's it. All right, simple, simple, simple. All right? So now what I want to do is, so the difference between the one that I just drew and the first one I drew is obviously it's perpendicular. So how hard is that? It's a perpendicular bisector. It cuts the segment in two congruent parts, and it's perpendicular to that segment. All right? Now, let me show you something that I think they're going to, but I haven't read it. This back. I haven't read the whole section, but I think I know what they're going to tell you next. All right. Let's say I put this point here. Right. What is true about the distance from here and this distance here? Do we know they're equal, or do they look equal? Well, how do we know? How do we know they're equal? You should be able to tell me. Well, of course you can read that, but that's not what I'm interested in. I'm interested in you telling me how for sure I know that this part right here is equal to that right there. It's super, super easy. Tell me. Well, this bisects, so I'm agreeing with you. So that means this is congruent to this. But I still don't know if that's true. Charlotte, tell us.
Side angle side. Or no.
Yeah. No, I'm happy with you. Side angle side. Now, the thing is, though, I'm not talking, of course, about this side right here, though, right, Charlotte?
You're talking about the bisecting, like the one in the middle.
The one in the middle. Thank you very much. Look, guys, I personally think everybody should be able to see that. I just don't think that's that hard. So we've now just proved the perpendicular bisector theorem. All right? That means any point that is on the perpendicular bisector is equidistant from the endpoints. All right, now come on now. I said a whole lot there. All right, but if you don't know any of the words, it doesn't make any sense. All right, so I said any point that is on the perpendicular bisector, so that would be what? Let me just make sure you're understanding me. All right, because again, I'm trying to encourage some of you guys who never asked me any questions because you're oh too shy, right? I'm trying to show you what this means. All right, so here is my point that I'm going to put anywhere on this perpendicular bisector. So if I put it right there, and I call this A, and I call this B, what is true about that point C? Carson, what is true? Put your hands down. I'm going to start introducing people to class. Say it. It's on the perpendicular bisector. Therefore, what is true? Virginia, help him. What sides? Good. Yes, brilliant. That's all that means. Right now, again, how do I know that's true? Because I can draw from here to here, and I can draw from here to here. And Charlotte, what do we create? That are what? Because side angle side. So like I'm trying to show you, even in 6 months when you forget everything I taught you, I feel like you should be able to recreate that. That's what I'm trying to get from you for you guys. There's no way. I don't remember everything. Most of the time, believe it or not, I recreate it. I can prove it to myself quickly if what I'm saying is true or not. That's what I'm trying to get you to do. But if you don't ever jump in, if you don't ever make some kind of, I think this is true, and although you're completely wrong, no one in here cares. Just say what you think. And eventually, when you say keep trying, eventually you'll start making connections. But if all you ever do is wait for me to tell you the answer, you're not getting any smarter. You're supposed to jump in and say, okay, this is what I think is true. And it might be what? Completely wrong. And that's all right. It's much easier to give it a shot on your own than me telling you what the answer is. All right? So once again, it doesn't matter where I put a point on the perpendicular bisector, it will be equidistant from the endpoints. Isn't that super easy? That's very easy. All right? So let's see what it says right here. If a point is on the perpendicular bisector of the segment that is equidistant from the endpoints of the segment. Converse. No reading it. Who remembers what converse means to do? What does converse mean to do?
Isn't it like how to like the opposite?
Not necessarily the opposite. All right? Now, I'm just going to put it up here, and I kind of understand what you mean. But if we call this, if a point is on the perpendicular bisector of a segment, that is called the hypothesis. And then you have the what? You have the conclusion. It is equidistant from the endpoints of the segment. All right? That's the hypothesis and the conclusion. That's the original statement. It's called a conditional, if then. If this is true, then this has to be true. The converse does what to the hypothesis and conclusion? It just what? It switches or flips it. Yes, however you want to think about it. All right? So, is it true that if the point is equidistant from the endpoints, then it must be on the what? Perpendicular bisector. Everybody okay with that? All right, that's the converse. Now again, I'm trying to just review with you what converse means also, because we kind of skipped that section and I probably shouldn't have, but I thought I could teach it as we go. All right, is everybody with me on this converse? All right. The conditional statement is in if-then form, and then the converse is just when you switch the hypothesis and conclusion. All right. So what are they saying? They're saying if I come back to my drawing over here and I put a point right here, let's say I put a point right there, and I say that, let's call this D, AD is congruent to BD, then what has to be true? That's all it's saying, and that is 100% true. All right, so again, those are just the different terms you're expected to know. Everybody okay with that? I don't think it's that hard. All right, do not think it's that hard. All right, let's see if there's something else now. All right, here we go. When three or more lines intersect at a common point, the lines are called concurrent lines. The point where concurrent lines intersect is called the point of concurrency. All right, so in this chapter, there are 4 different points of congruency that we're going to be discussing. All right, and the first one is called the circumcenter. All right, and the circumcenter is simply if I were to draw the perpendicular bisectors of a triangle, they would all meet at one point. All right, and now I'm going to try to demonstrate that for you up on the board, and you should go, oh, that makes perfectly good sense. And I'm actually going to kind of say, kind of like the verbal proof. You don't have to write it down. I just would like you to say, okay, that makes pretty good sense. All right, so please, I'm going to try to do it right here. I'm going to draw a triangle, and then I'm going to try to draw the perpendicular bisectors. All right. So now, what I'm going to do is I'm going to come over here, and I like to draw something perpendicular and then move it. So I'm trying to draw something perpendicular. Now, does it have to go through the vertex? I don't think so. Right? Because watch, if I go through the vertex, does it have to be equidistant from the other points? No. Right? So I'm trying to find it. Trying to think about, that looks pretty good to me. Right? So, what's true about any point that's on that line? And I'm going to label these points now so we can talk better about just, we'll call this A, B, and C. So what's true about any point on that line? Say it. From what, though? Somebody help him. What?
Like the points on the end, bottom part of the triangle, point B and C, are equal, or they're equal distant to any point that's on.
Summarize.
Any point on the perpendicular bisector is equidistant to B or C.
B or C, right? Is everybody with me? So any point on this perpendicular bisector is equidistant from B to C. Everybody okay with that? Yes? All right, I'm going to draw another one. All right, so I'm going to try to draw something. Watch. So I'm trying to do it perpendicular, right? Now I'm trying to draw perpendicular to AC. Does everybody agree with that? Everybody good? So is that a perpendicular bisector, though?
No.
Is it perpendicular?
Yes. No.
Is it perpendicular to AC?
Yes. Yes.
Right? Is it bisect AC?
Yes. No.
Look and see. This is what I'm trying to say. It doesn't matter if you're right or you're wrong. If you don't know the answer, you're supposed to say, I don't even have any clue what you're talking about. Would you please just explain it? I'm going to ask one more time. Does it look perpendicular? Does it look perpendicular to AC?
Yes.
Is everybody okay with that? Does it look perpendicular to AC?
Yes.
Right? Does it bisect AC?
No.
If it bisect AC, guys, here's what would be true. This distance right here is the same as this distance right there. Does it bisect AC, guys?
No.
No. Does everybody agree with that? What?
If C doesn't if the green line doesn't bisect AC, then how does the purple line bisect AC? Because it's not at the vertex. I don't understand how, if it's not at the vertex, how it bisects.
Who said a perpendicular bisector had to go through the vertex? You did, not me. Do you understand what I'm saying? That's a very good question. Because in your head, you're thinking that the perpendicular bisector has to go through the vertex. Does it have to go through the vertex? It will go through the vertex if it's an isosceles triangle or equilateral. But those are exceptions. So that's why I try to draw something a little different.
So in order for that to bisect AC, the AC would have to be the same length on both sides?
Yes.
Okay.
I think I understand your question. So you tell me, I'm going to try to draw this. All right, I'm going to try to grab this now. I'm going to try to make it a, oh man. I'm going to try to make it a perpendicular bisector. So to me, that's not too bad. Not the greatest, but not too bad, right? Can you look at that and say, is that bisect?
Yes.
Kind of close, right? I could measure it, but it looks kind of good, right? So any point that's on that green line is equidistant from what? From what?
AC.
From A and C, right? So now tell me this. So this point right here. Now this is if I'm doing a good job. You'll be able to tell me something. This point right here is equidistant from what?
B and C.
A and C.
And also,
A and C.
does everybody see that? So if I were to draw from here to here, and I would draw from here to here, and then I would draw from here to here, what's true about all blue lines?
They're equal distance.
They're
from each other.
equidistant. How about that? Now, come on, I don't think that's that hard. And kids just go, oh my gosh, that's the hardest thing in the world. Right? Okay, so now what I want to do is I'm now going to try to draw another line. Let me see. So here we go. So now what I'm going to do is I'm trying to draw something perpendicular. That looks pretty good to me. We'll find out here in a minute. Does that look perpendicular?
Yeah.
Pretty good, not the greatest, but still pretty good. Does that look like a bisector?
Yes.
That looks like a perpendicular bisector. Does everybody see that? So now, any point that's on that line is also equidistant from what?
B and A.
B and A. Beautiful. So now, why is this point down here called a point of concurrency? They all come to that point. Those three lines meet at that point. That's a point of concurrency. And what's true about the three perpendicular bisectors of a triangle? That point of concurrency is equidistant from what? Well, they're not called all the points. They're called the vertices. Is everybody with me on this? Everybody good with that? So this point right here, does everybody see the blue lines? It's the same thing. Does everybody agree? Now, it's actually kind of something very practical. All right? If I wanted to have a point equidistant from 3 points, I would construct the what? 3 perpendicular bisectors. Now, why is it called a circumcenter? Because, watch, this is something nice about the iPad. If I pull that out, and I were able to now move this circle, because I didn't do a very good job. Yeah. All right, you can see how accurate I am. Uh-oh. These 3 points should, if I did a pretty accurate job, we call that circle is circumscribed around that triangle. Does everybody see that? All right. That's all. All right. Now, again, there is some practical use for this. You know, if you wanted to, let's say, this is one of the things they'll say in the book, like if these are 3 classrooms and you want to put a water fountain equidistant from the classroom, you could draw the perpendicular bisector and you could put it right exactly where it's equidistant. All right. So again, there are some applications to it. But again, I feel as if that's not that difficult, right? And for me, I can reproduce that more than I can what? Memorize that. All right. I just think that's easier way to do it. All right. So again, the 3 perpendicular bisectors form the circumcenter, because that triangle, all right, can be, the circle will be circumscribed around that triangle. Is everybody with me on that? All right. So here we go. The next one is called the incenter. All right. And the incenter happens to be, we'll talk about an angle bisector. All right. So here we go. I'm going to draw an angle. And then what we're going to do is I'm going to try to bisect it. All right. So here we go. Follow me. Just see what we're doing. Trying to draw that angle bisector. And that's pretty close to the angle bisector. Not exactly, but pretty close. All right. So if I put a point on the angle bisector, what's true about that point? All right.
It's equidistant from both angle parts.
That's exactly correct. All right. Now let's prove that. All right. Now let me ask you this. The distance from a point to a line is the shortest distance. Is that the shortest distance? That looks like the shortest distance to me. How do I know that's the shortest distance? Because it is very smart. Because it is perpendicular. All right? The shortest distance from a point to a line is the perpendicular. Do I agree with that? So now if I come down here and I were to draw the line, again, which you can tell it's not very good. I should have done a better job. I'm going to do a better job because I just can't stand it when it's that bad. Alright, so maybe that's a little better. Alright, we'll try again. Try this dot right here. I try to draw a perpendicular down here. Try to draw a still not very good. Alright, but hopefully you see the point, right? Now, this is perpendicular, do you agree? This is perpendicular. Now, why is that congruent to that? Good for you, tell me.
Because the point bisects both
Nope,
sides.
nope. I want a reason. Kind of like the last one. Charlotte, you may have to tell them again. Oh, good. Hold up. Thank you, Tyler. Go. Well, this angle bisector means that's congruent to that. No question. I'm trying to figure out if these are congruent. Dalton. Side. So I'm agreeing with you. This is true. That's definitely congruent to itself. So it would be.
Side angle.
Now, listen, my problem here is this. Listen to my problem. My problem is for you this. I mark that. That's what we're trying to prove is true. So maybe I should do this. Maybe I should draw this here. That's what I'm trying to prove is true. You with me? So now, someone else, come on. Come on, guys. Those of you guys who want to do better. All right? If you want to do better, now it's the time to take a shot at it. Tell me.
Side angle.
Side angle, angle. Or angle, angle, side, right? It's what? This angle, and this side is congruent to angle, angle, side. Do you agree? So now the triangle's congruent. So that side has to be what? So we now know that any point that's on the angle bisector is what? Any point that's angled to the is equidistant from the, well, no, perpendicular is assumed there. It's just from the side, like you said, from the side of the angle. Everybody with me? So if I draw an angle, all right, now what he's saying is true. So do you hear me? What you're saying is true, but if I draw from here to here, is that the distance to that side? Yes or no? Come on, this is where you're getting smarter. Is that the distance? Well, see, mine, it looks so much different on mine than the board. Or it's kind of weird, actually. So let's do it this way. Is that the distance to that side? No, because it's not what? It's not perpendicular. So when I say the distance to the side, we automatically know I'm talking about the what? The perpendicular. You with me? So from here to here. That would be the perpendicular. And like I said, it's so weird looking at my iPad and looking over there. So again, we would have to assume that that's true. Does everybody agree with me that whenever I say to draw the distance from a point to a line, we're automatically constructing the perpendicular because that's the shortest distance. Does everybody agree? All right. So this is always true. So that's always true. All right. Now, let's talk about it. The incenter. All right. Wow, I'm almost done. So the incenter on a triangle. Please watch. I'm going to make another triangle. Now, the reason we call it incenter is because it's going to inscribe a circle. We're going to inscribe a circle. So what does that mean? So I'm going to draw the angle bisector here, guys. Watch this when I draw the angle bisector. So if I draw that, looks pretty good like an angle bisector. Not exactly, but close. So that means any point on that line is equidistant from the what? Not the vertices, from the sides of the triangle, or from the sides of the angle. So again, let me make sure I'm with you. Come on, guys. We're almost done here, guys. You got to have a lot of homework tonight. Sorry, but this was a good lesson. Does everybody agree with that? So any point on the angle bisector is equidistant from that side, those two sides. Agreed? Now what I'm going to do is I'm going to draw the next angle bisector. Here's the next angle bisector from here. So I'm going to try to draw the angle bisector. That looks pretty good. So now that line right there, any point on that line, so if I put a dot right here, that's equidistant from what? Okay, let me label this. Sorry, guys. A, B, so we don't. So this point right here is equidistant from what? Say.
Because it bisects.
Be careful, be careful, be careful. A little bit different. Tell me, Reed.
Both sides.
Well, I labeled the sides. What sides now?
BC and AB.
Yes. So if I'm talking about this right here, on this right here, that means the distance from here to here is the same as the distance from here to here. Does everybody agree? And now, come on now, if I'm talking about this angle bisector, now this right here is the same distance from here to here. Does everybody agree?
Yes.
And from here to here, correct?
Yes.
So what's true about all three of these? They're congruent, and they're equidistant from not the vertices this time, but from the what? From the sides. All right, and like I said, I never memorize this. I reproduce it every single time. And it's just easy for me to learn it that way. All right, so now, if I've done a good job with this, if I make a circle and I blow this circle up, wow, that's actually pretty good. Look at that. We say that it's what? It's inscribed in the circle. All right, I'm sorry, it's inscribed in the triangle. Let me hear me on that. All right, so again, two major points today. All right, and then tomorrow I think we have the orthocenter and the centroid. All right, so today we learned circumcenter and incenter. All right, circumcenter is equidistant from the vertices. The incenter is equidistant from the what?
Sides.
That's the big deal to me. All right? I don't have it memorized. I'm trying to tell you, I think the presentation where you actually physically see what I'm drawing is much better. All right? And again, I appreciate some of you guys who tried to participate a little better today. I'm telling you, if you get involved, I promise you, we can have a great next 27 weeks. All right? It's really, you have to do the homework. You have to participate. When I post the solutions, if all you're doing is going to solutions and writing things down, it's hurting you. It's hurting you. All right? Don't take shortcuts. I'd much rather you come to me and say, look, man, I couldn't do my homework, because really homework plays really nothing in your overall grade, right? Which is the way I would run business. I wouldn't even collect your homework ever. Or if you want to make good grades, you got to do what? You got to do the work. There's no escaping that. You have to do the work. And you can't do the work on Thursday, the day before the test. It doesn't work that way. All right? You got to find time every single night to get it done. All right? So, again, I think I did a great explanation. All right? Hopefully you feel the same. But the problems are not that difficult. All right? The bell's about to ring. Very nice day today, guys. Very good. Do the work, please. All right, good job. Yes, ma'am.